everybody, it's Mrs. Yake. Today I'm going to show you two different ways of calculating instantaneous rate of change, aka slope, on a given curve at a given point. If you want to take a few notes, I would just recommend that you draw this picture, some arbitrary nonlinear curve. And what we've been doing is looking at specific points, and this is what we do in upper level mathematics. We generalize. And so we're going to pick some random point A. This is my function. I've labeled it f of x. And so we are going to pick some random point A, comma, f of A. And what we've been doing in class is starting by picking a different point kind of close. And we'll just say, oh, how about we pick this point here, x. And so this would be the point x, f of x. And then what we did is we just found the slope between those 2 points. And we thank the good Lord for our slope program. So, but let's just do this in general then. The slope is the change in y values over the change in x values. Now what we did then is we found the slope of this secant line, and it was an okay approximation, but we're really looking for the slope of the tangent line, and so it could be a lot better. And so we gradually brought this point closer and closer and closer and closer. And actually what we're going to do mathematically is take the limit as x approaches a. This is called definition 1, and the only reason I'm calling it this is because this is what your book calls it. It's just one method of finding the exact rate of change, the instantaneous rate of change at a specific point. So I want to do one example with you, and I'll show you the other method. We'll do the same example so you could get the same answer. And then we'll try some of these in class tomorrow. So the function is going to be lame, boring, I know. F of x is x squared. And we want to find the instantaneous rate of change at the point 2, 4. And so looking back at our cloud here in definition 1, we need to know some things. We need to know what the function is. So when you approach these problems, I recommend that you come off to the side and kind of list all the things you need to know. So f of x is x squared. We need to know what f of a is, and we need to know what a is. And so our a is really our x coordinate and our point of interest. So a is 2, and that makes f of a then the y coordinate, depends on what a is, 4. And so we're going to kind of plug everything into this equation. It's the limit as x goes to a, which in this case is 2, of f of x, which is x squared, minus f of a, which is 4, all over x minus a. These are the kinds of problems that we have been doing up until this point. And so what I've told you before is if you're trying to find the limit as x approaches 2, try plugging in 2. If you try to plug in 2, you get a 0 on the bottom. That does not mean that the limit does not exist necessarily. It means maybe I need to reduce this fraction a little bit and see what happens. So take the limit as x approaches 2. Take this, I see this numerator and it jumps out at me and says, hey, I'm a difference of 2 squares. So x plus 2 times x minus 2. Then the x minus 2's will cancel, and then I can plug 2 into there, and I get 4. So if we wanted to draw a picture of that, here's my curve y equals x squared. Whoops, not very symmetrical, sorry. At the point 2, 4 up here, you have a slope of 4. All right, so here we are again with a new picture. It's the same picture actually. And there's another way of doing it. There was definition 1, the limit as x approaches a, and whatever we just had in the cloud. And now there's something called equation 2. I know, it's bugging me. You want to say definition 1, definition 2, or equation 1, equation 2. I don't know. This is how your book does it. So I'm going to refer to them as definition 1 and equation 2. Equation 2 is doing the same thing. It's still picking a point close to our point of interest and then moving it closer. It's just how it labels this point. And so instead of using x and f of x, we're going to say I'm going over here a distance of h units. And if you're going, and it doesn't have to go to the right, but we're just going to go to the right. If it's a distance of h units to the right, then this point would actually be called a plus h. And this ordered pair, I forgot to label this. This is a f of a, like we said before. This ordered pair then is kind of long, but it's a plus h, comma, f of a plus h. All right, so again, we have our 2 points. They form the secant line, and then we're going to take that point closer and closer, but we're still going to find the slope between these 2 points. And the slope between these 2 points is the difference in the y values over the difference in the x values. So the difference in the y values would be f of a plus h minus f of a over, now here's where it gets kind of cool, difference in the x values would be a plus h minus a. And a plus h minus a is just h. Okay, and now instead of taking the limit as x approaches a, we're really taking the limit as a plus h approaches a. But another way of saying that is this little distance right here, where we want to make it nothing. So we're really taking the limit as this distance between these 2 points goes to 0. So we'll cloud that up, and then we'll try the same example that we just had. The function is, really easy, simple example, but the function is x squared. I want to find the instantaneous rate of change on that function at the point 2, 4. So looking back at our cloud, what kinds of things do we need? We need to know, well, we need to know our a. Our a is 2. Our f of a is 4. And, what is this f of a plus h? That's going to be interesting. Our a is 2, we already said. So I really need to evaluate this function at 2 plus h. And so I'm going to take the limit as h approaches 0 of whatever my function is evaluated at 2 plus h. I'm going to have to go back and do that in a minute. Minus my f of a, which is 4, all over h. I really hope you can hear that crow outside my window. It's very early in the morning while I'm doing this. That's great. All right, so f of 2 plus h means I need to take this whole quantity, 2 plus h, and stick it in this function here. If I asked you to find f of 5, it would be 5 squared. If I asked you to find f of negative 3, it would be the quantity negative 3 squared. If I asked you to find f of triangle, it would be triangle squared. And so people are all okay when I'm asking you to find f of one thing. And so now I'm asking you to find f of this quantity, 2 plus h. So just call it blob and plug it in there, and it becomes 2 plus h squared. Now, we had some problems like this the other day, and you try and plug 0 in for h, and you get undefined. That means that this function at 0 is undefined, but that doesn't mean that the limit is undefined. And so we're going to do some fancy algebra and see what we can do with this numerator here. Expand it a little bit. And anybody who's anybody knows that when you square a binomial, you get a, say it with me, trinomial. And this is the trinomial that you get. That squared plus these two things multiplied together, squared, plus that squared. Oh, this might be kind of nice. Minus 4. So the 4's cancel. We're going to do some more algebra. And we're going to take the limit as h approaches 0. Okay, what can I do here? Can I just go hack crazy? No, I'm actually going to think of these one at a time because I want to follow all the rules, as I know you do. And then I can start simplifying some things. And so it's the limit as h approaches 0 of the quantity 4 plus h. Now plug in 0 and you get 4, which is the same answer we got, whoops, it's the same answer we got when we did it the other way. So you've got definition 1, there it is in the cloud, and I know what you're thinking, wow, definition 1 is way easier. And you are right. Equation 2 is a little more cumbersome, but I have a crystal ball and I know where we're going with this, so just trust me, and we'll try some problems tomorrow. Thanks. Have a good night.